Hello student friends, welcome to Let Us Learn YouTube channel. Today we are going to discuss binary adder in digital logic design for JNTU, Anna University and NITU syllabus. Now here we are going to discuss the 4-bit binary adder, that is 4 full adder is connected in cascade. As I told, here we are using the binary adder, or otherwise it's called as a parallel adder. So in your 4-bit binary adder, we are using full adder circuit, which is capable of adding two 4-bit number, resulting in a 4-bit sum and a carry as output. That is, we are giving two 4-bit number and then we are taking four 4-bit sum and a carry as output. So in this, how we are supposed to add? The bits are added with full adder, starting from least significant position, that is LSP, or least significant bit, LSB, to form the sum and carry bit. So now we are going to discuss the 4-bit binary adder. So in this 4-bit binary adder, the block diagram is given here. This block diagram, what it states, we are using the 4 full adder which is connected cascade. That is in the form of back-to-back connection. It is framed like this. So here we are having the input A0, A1, A2, A3. Similarly, we are having the input B0, B1, B2 and B3. So here for the A, we are taking the values A3, A2, A1 and A0. And then for the B, we are taking B3, AB2, B1 and B0. So totally we are having two 4 bits value it is given in the full adder. For the full adder, it needs 3 inputs, that is A0, B0 and Cin is also input. And we will get the two outputs, sum and carry will be here. This is a carry. So already we discussed that OR gate is an odd one reductor. Odd one reductor means whenever the value it has odd number of ones in the truth table, at the time we are getting the output as a 1. See, let me explain the symbolic expression of the XOR gate and then truth table. So here this it shows the symbolic representation of XOR table, XOR gate. This is the input A and this is the input B. So whenever the A is 0 and B is 0, we are getting the sum value is 0. This is your sum. And then when A is 0 and B is 1, we are getting 1 as output. Why in sense? This B we are having only 1. So that is coming under the odd one reductor. So we are getting the output as a 1. Here when A value is 1 and B value is 0, we are getting the output as a 1. Since these inputs are, we are having only 1. So it is coming under the odd one reductor. And then A value is 1 and B value is 1. So here it is a even ones are there. So we are not getting the output. The output is 0. Similarly, I am going to explain this same value in the form of 3 inputs, that is Cin. I added one more input in this XOR gate. So A, B, Cin is given and then sum is given, some value is given here. So as I told, the XOR gate is a odd one reductor. So here A is 0, B is 0 and C is 0. So here no 1 is that, so the output is 0. So here A is 0 and B is 0 and C is 1. So we are getting the output as a 1. So this is coming under the odd one reductor. So A is 0 and B is 1 and C is 0. So we are getting the output as a 1 because this is coming under the odd one reductor. Similarly, next value A is 0, B is 1 and C is 1 and we are getting the output is 0. We are not getting a correct output because it is not coming under the odd one reductor, since here we are having the 2 or even ones are there. So it is not applicable. And then next one is A value is 1, B value is 0 and C value is 0. So this is coming under the odd one reductor. So we are getting the output as a 1. Next to that, see here A value is 1, B value is 0 and C value is 1. So this here we are having the even one circle. So it is not applicable. Here A is 1, B is 1, and C is 0. This is also not applicable. And then the last one is A is 1, B is 1, and C is 1. So here we're having three ones. So it is a odd ones are there. So we are getting the output as a 1. This it shows the truth table of the XOR gate. Now we will explain. I'll explain you the in-depth concept of the 4-bit adder, binary adder. Now I'm going to explain the 4-bit binary adder with the example for the block diagram. So here, as already we discussed, we are having the 4 full adder. That is full adder 1, 2, and 3 and 4. So 4 full adders are there. And then we are having the input A0, A1, A2, and A3. This is the one set of 4-bit numbers, and then B0, B1, B2, and B3. This is another value. So here it is given the values given here A1, A2, A0, A1, A2, A3, and B0, B1, B2, B3 values given. So the value of A, see A value is given in the form of, that is like A0 is given as A0 is 0, and A1 is 1, and A2 is 0, and A3 is 1. Like this, B0 is 1, B0 is 1, and B1 is 0, and B2 is 1, and B3 is 0. So now the value is given here. And then C in for the addition, we have to take as a 0 as an input. First, let me explain this only one set of full adder, that is full adder 1. So the value which is given here is the full order. Here the A0 is 0, and A1 is, sorry, A0 is 0, and B0 is 1, and C in is 0. Since already we discussed that OR gate is a odd one detector. So here we are having odd number of ones. So the sum in this, that is S0, we will get output in the form of 1, as already we discussed in the truth table. So here the S0 value will be 1. Similarly, let me explain for the next full adder, set of full adder. So here A1 value is 1, and B1 value is 0, and then carry. Before going to the carry, let me explain the carry. The carry, already we got the output is in the form of AB, BC, AB plus BC plus CA. Now if I substitute that value, that is A value, B value, and C value here, let me check what is the value I can take. So A value is 0, 0 into B value is 1, plus B value is 1 and C value is 0. So 1 into 0 plus C value is 0 and A value is 0. So if I add, finally I'll get 0. So here the carry value is 0. So here the carry is 0. Let me go for other set of the full adder 2. That is full adder 2. Here A1 is given as a 1, and B1 is given as a 0, and C1 is given the value as a 0. So here, if I here also we are having A1 values 1. That is, we are having only one odd number 1 is present in the input. So here the sum S1 finally will get as a 1. So sum we are getting as 1 here. So S1 is equal to 1. Similarly, if you check the carry here, that is 0 into 1 will get 0, and then 1 into 0 you will get 0, and 0 into 0 you will get 0. So obviously here also we are getting the carry as a 0. Next, for the third set of the full adder, that is full adder 3, A2 value is given as a 0, and B2 value is given as a 1, and C2 value is given as a 0. So here also we are having only 1, that is odd one detector. So S2 we will get value as a 1 because odd 1. So whenever the odd number of 1 is present in the input, we are getting the input as a value of 1. So here S2 value is 1. Similarly, we are doing for the third set, it is fourth set, that is A3 value is 1, and B3 it is given as a 0, and C3 value is also 0, because see here 1 into 0 will get 0, 0 into 0 will get 0, and 0 into 1 we will get 0. So obviously here also we are getting 0. So finally here also we are having only one is there. That is odd one is present in the input. So the output sum is equal to S3 is equal to 1. So finally we got S3 value is 1. So the carry here, the carry is also 0. See here, as per given in this addition, let me do this. See 1 plus 1, already we are aware of that addition. 1 plus 0 plus 1, we will get 1. Carry is 0, and 1 plus 0 is 1. Carry is 0. 0 plus 1 is 1. Carry is 0. 1 plus 0 is 1. So finally we got the same value, that is sum is equal to S3, S2, S1, S0. That is equal to 1, 1, 1, 1. So this value, decimal value of this binary number is 15. Since we are having the two inputs A and B, this value is 10 in decimal number, and this value is 5. So 10 plus 5 will get 15. So finally we got the output the correct form. So this is the output carry, and this is the sum. So output carry is 0, and then sum is 1 1 1 1, that is double 1 double 1, and then this it shows the significant place, that is 1 2 3 and 4. Since we are dealing with the 4 bit, we are getting the 4 significant places. If you deal with 2 bits or 3 bits, it is depending on the 2 bit means 2 places will be there, 3 bit 3 places will be there. So this is the depth explanation about the 4-bit binary adder. I hope you enjoyed this video. Thank you for watching.